Hi everyone, my name is Zhao Geng. I'm from Swansea University in UK. Today, I'm going to present our work, which is entitled Realizing Translation Variation, Shakespeare's Othello. This is a collaboration project between the various computing groups in Computer Science Department and the College of Arts and Humanities in Swansea University, UK. For the overview of this presentation, though, I will present the motivation behind this project, and in section 2, I will review the previous work on text realizations. In section 3, I will describe our source and background dataset, and in section 4, I will explain how are the original documents processed before being input to the realization. In section 5, I will illustrate our structure-aware tree map for metadata analysis. And in section 6, I will present the focus plus context parallel coordinates for translation variation explorations. And in the end, I will wrap up with the conclusions. Introduction. Recognized as great works of world literature, Shakespeare's poems and plays have been translated into dozens of languages for over 300 years. Also, there are many retranslations into the same language. For example, there are more than 60 translations of Othello into German. Every translation is a different interpretation of the play. These large quantities of translations reflect changing culture and express individual thought by the authors. They demonstrate wide connections between different world regions today and reveal a retrospective view of their cultural, intercultural, and linguistic histories. Researchers from Arts and Humanities at Swansea University are collecting a large number of translations of William Shakespeare's play Othello. So, based on these large collections of the documents, what is the realization can be used in this project? The first though is because the realization, there are three major goals of the realizations. The first though, it can present the data with different facades by the graphic metaphors. And second though, realization could help users to analyze the data in more detail. Thirdly, with a lot of interaction spots, the realization could help human beings to explore the relationships and patterns in order to make some new hypotheses. And also, it is also because our dataset is quite complex and it is multidimensional. Except for the textual retranslation documents, for each translations, we also have a list of the metadata associated with it, such as the author of the translations, the place where it has been published, the year when it has been published, and how many times this translation has been republished, which is referred to as the popularity. So based on this complex dataset, the domain experts they define some exploratory specifications for us. And they want to know, in particular, where, when, into which languages has Othello been translated, and how have translators influenced one another, how do Russians vary globally or locally, which translations is more similar to the original play. Because this is only the beginning of our project, and this is just the work in progress. So in this presentation, we will focus on the German translations of the Shakespeare play Othello. Related work. Since 2005, from the major realization conferences, we can observe a rapid increase in the number of text realization prototypes being developed. As a result, various representations for text streams and documents are proposed to effectively present and explore the text features. In this section, we are only focused on the multiple document realizations, such as the same river, parallel text clouds, dot burst, and spark clouds. The parallel text clouds is quite similar to our work. In this work, the words in each document, each vertical axis represents a document. The words in each document are summarized in the form of text clouds along the vertical axis. When clicking on a word, the same word appearing in other vertical axes is connected. One disadvantage of this realization is its incapability to display groups of words which are missing in one document but frequently appear in others. When we explore the variations among the Othello translations, the domain experts would like to know groups of words which a particular author never uses but which frequently appear in other authors' work. Also, brushing multiple words in different documents might introduce clutter due to the crossing lines in parallel text clouds. We also observe some interesting realizations which can depict time trends over different documents, such as the spark clouds, which integrates a spark line into the text cloud to convey trace between multiple text clouds over time. There are also some other related work which has not been published but of significant importance to our work, such as Ben Fry's work on the origin of species, the preservation of favourite traces, and also on the Stephen Antill's work, Understanding Shakespeare's toward a visual form for dramatic text and languages. For your interest, we provide the website links, the link to the website of this work. And how the retranslations looks like in the Shakespeare play Othello. Let's have an example. On the very top line in red color is the sentences in the original play, and in the following list are the retranslations of the same sentences in German. And also the sentences in red colors are the English back translations of the German sentences. As we can see that for some of the words, such as fair, black, are varied quite a lot along the time series by different authors. This is the reason why we have to study this problem, and we want to see how these varied with each other and what's the reason behind it. Also, the domain experts from arts and humanities have collected 57 different German translations of Shakespeare's play Othello, and for each translation, its metadata recorded includes the author name, publication date, country, title of the play, and impact index. The translations were written between 1766 and 2006 in 7 different countries defined including German, East German between 1949 to 1989, West German between 1949 to 1989, German since and also the German since 1989, Austria, Switzerland, and England. The impact indexes refers to each translator's productivity and reputation. It includes the republication figures of each Othello translations. Figures were derived from the standard bibliography of Shakespeare's in German. The index has 5 levels ranging from 1 to 5, where 1 means that the translator is not listed in the bibliography, and 5 means that more than 50 publications and republications by the translator are listed in the bibliography. And in this scatter plot, it shows the chronological distributions of our collected documents. The x-axis is mapped to the publication date, and y-axis is to the different countries. The size of the dot is mapped to the impact index. So before the original translation can be analyzed within our realizations, we need to generate various features from the textual information and transforming them into the numerical vectors. In this work, we process our original text in 5 steps, namely document standardization, tokenization, stemming, vector generation, and similarity calculations. The major outputs includes making concordance of each document and computing their similarities. Because the Othello translations are collected from various sources, some of them from PDF, some of them are TypeScripts, but mostly are books. We firstly transform and integrate them into the standard XML format. And next, document tokenization breaks the stream of the text into the list of individual words or tokens. During this process, common words carrying little meanings which are not of interest to domain experts are eliminated from the token list. Furthermore, stemming reduces all of the tokens to their root forms. And based on the cleaned and standardized token list, we are able to generate concordance table for each document by counting the frequency of every unique token. LSI model. For in-depth document comparison, we also need an objective document similarity measure. The document expert from art and humanities suggests a list of high-frequency keywords as a search query. This keywords list can be extracted from multiple interesting documents. The similarity between our collected translations can be measured using the LSI model, which is short for Latent Semantic Index. This model is widely used in information retrieval, where the list of terms associated with their weight is treated as document vectors. The weight of each term indicates its importance in the document and is given by the TF-IDF scale. We use TF, its term frequency, to refer to the number of times a term occurs in a given document, which measures the importance of the word in a given document. The IDF, which is the inverse document frequency, as its name implies, is the inverse of the document frequency. The document frequency is the number of the documents in which the word occurs within a collection of documents. Therefore, the weight of the term in document can be defined as the multiplications of the term frequency values and inverse document frequency values. Then the document can be represented as a vector with each dimension replaced by the term weight. Because a large number of words in the search query might lead to extremely large and high-dimensional document vector. Therefore, we use the singular vector decomposition to perform dimension reduction. Then the similarity between the two documents can be measured by the angle between these two vectors. And these similarity measures are generated for all of our Othello translations. This information is featured in our tree map and parallel coordinates. Structure-aware tree map. As discussed in the background data, the metadata of each document includes author name, plate title, date, place of publication, and impact index. The scalar plot in the background section is able to present the overall historical distributions, but it cannot provide aggregation of the data. For example, if the user wants to explore or rank the total number of translations or the total number of republications in any century, decade, or country in our document collection, the scalar plot is unable to convey an answer. Next to this, we observe that the metadata can be arranged in a hierarchical structure. For example, each century breaks down into the several decades. In each decade, a few translations are published in several countries. In each country, several authors publish their work. For each author, his translation has an impact index. Given this structure, we are able to generate a tree map realization. But the traditional tree map is able to compare the node values in any tree level, but it lacks the ability to show the entire tree structure intuitively. For tracing the tree map structure, it's necessary to only list the relevant substructures, which shows ancestors and descendants of the interested nodes. The degree of interest tree provides a clear hierarchy at a low cost of screen space by changing the viewpoint and filtering out the uninteresting tree nodes. In addition, it offers instant readability of the node labels. Therefore, we adopt the linked views using both the degree of interest tree and tree map to enable structured tracing. As we can see from this image, our system is composed of two parts, namely the control panel and the structure-aware tree map. The control panel is shown on the left half part. It extracts the ontological hierarchy information from the input datasets and sets up the configuration for the realization. The user is able to change the order of hierarchy or reduce the number of hierarchies by moving the graph nodes. The right half in this image is the structure-aware hierarchical realization. It's containing the coordinated views of the squarified tree map and the degree of interest tree. As we traverse back and forth between the intermediate levels of the tree map, the degree of interest tree clearly keeps track of how each selected node is derived from its ancestors. Also, the area of the leaf node can be either mapped to the impact index, the similarity measure, or the quantities of each translation. Our tree map system helps users manage their documents, such as ranking the documents according to different criteria, analyzing the global features of the metadata, and selecting the interesting documents. It can be scaled up to include new datasets such as translations of other works by Shakespeare and enable users to explore common patterns in the metadata. The degree of interest tree can initiate the searching task by which the user is able to search terms in any hierarchy. Since the collection of our German translation is still expanding, our tree map will play a more important role in the metadata analysis. After we finish the metadata analysis using tree map, the domain expert will select some interesting documents from the large collection from our corpus, and then we will use parallel coordinates to enable the multi-document comparisons. The parallel coordinates introduced by Alfred Inselberg is a widely used visualization technique for exploring large multi-dimensional datasets. The textual information, as we discussed in the text preprocessing section, the textual information of each document can be transformed into a vector. In our parallel coordinates, we encode the document dimensions as term functions. In this image, it's a major interface. It's the main interface of our focus plus context parallel coordinates. The domain experts from arts and humanities selected 8 interesting translations according to their similarity score. For initial analysis, we chose a significant passage from the play Othello's Big Speech in the Act 1, Scene 3, the longest single speech in the play, which is about 300 words in Shakespeare's text. And in this image is an overview of our visualizations of the focus plus context parallel coordinates. The column on the far left displays the list of selected keywords. These are most frequently occurring significant words in the document corpus. The parallel coordinates present a focused view of keywords focuses. Each document is represented by a vertical axis in order to maintain a unified skew. The height of each vertical axis is made proportional to the range between each document's minimal and maximal word focuses. Zero focuses simply mean that a keyword has not occurred in that document. The thickness of each vertical axis is mapped to the document's similarity with others in terms of the LSI score. A thicker line means a higher similarity value. The number of occurrences of each keyword in each document is connected by a polyline. Each polyline is rendered in different color to enable visual discriminations. The text boxes below the parallel coordinates is the context views for keywords selected by the users. And also, it shows the inter-sentences from the original text where each selected keyword occurs. We also apply the add boundaries to enhance the visual clustering, and the user is able to control the curvature of the edge. Curves with the least curvature becomes a straight line. We also provide a list of interaction spots, such as selection, brushing, and linking. As the user selects individual multiple keywords, the corresponding polylines are rendered. The user can also select various function levels in any document, and the corresponding keywords having that frequency are displayed. Along with the selection and brushing, the text boxes, which show the context views, keeps updating. Our system also supports composite brushing such as AND brush and OR brush. We can use an AND brush to obtain all keywords which occur exactly once in every document. The words used by all the translators, regardless of the translator's reputation and impact. As we can see here, these 5 words appears exactly once in every document, and the context and the text box show the context views of each document, of each the occurred words in the document. This is quite interesting findings for the domain experts. And also by using the AND brush, and we could find these two words have the sort of strong correlations across different documents. The conclusion. The focus in this work, we have introduced the interactive system for exploring, for presenting, analyzing, and exploring the variation among different German translations of Shakespeare's play Othello. A structure where tree map is developed for metadata analysis and focus plus context parallel coordinates is developed to investigate the variations among the translations. Our parallel coordinates incorporate an objective similarity measure for each document using LSI model. Also, various interaction spots are realized to facilitate the information syncing measure, overview first, zoom and filter, and detail on demand. Our realization is evaluated by the domain expert from art and humanities. But because it is just the beginning of our project, in the future, we would like to add more advanced features to the parallel coordinates, such as video clustering. Also, we will expand the analysis of the whole play to the we will expand our analysis to the whole play of the Othello, and also we will keep on collecting more translations and further statistical and linguistic analysis, which could extract more advanced feature-based semantic features would be implemented. Thanks for your listening.